Okay, so we're going to do adding and subtracting rational expressions with like bases. So this is the notes for the homework. So when you're adding and subtracting them and they have like bases, think about it as common denominators. So for example, if I gave you negative 5 over 3 plus 2 over 3, you're going to combine your numerators. So negative 5 plus 2, that's going to give you a negative 3. Keep your denominators, which is the 3, but in this case it would be negative 1. Now, another random example. So if I gave you 15 over 10 plus 4 over 10, again, combine your numerators and keep your denominator. Okay, simplify if needed, but there's nothing to do. So the same idea goes here. So if I have x squared plus 5x over 4x squared plus 5x minus 6 minus the 3x over 4x squared plus 5x minus 6. Notice how your denominators are the same. Okay, so you have common denominators, so they're telling you to combine the numerators. Whoops. So combine your numerators and keep the denominator, the common denominator. Factor and simplify the remaining expression if possible and if needed. So what I'm going to do is I'm going to combine x squared with the like term. There's nothing here with its squared, so I'm just going to rewrite x squared. Now 5x, I can combine it with 3x, but it's actually a minus 3x, so 5x minus 3x is 2x. And then I'm left with 4x squared plus 5x minus 6. Now, it tells you to factor and simplify the remaining. So look at the top. If you can factor, you need to do that. So I need to factor out an x. So x plus 2 is left. At the bottom, your a is greater than 1 and there's no GCF, which means that's the one where you're going to have to multiply. So you're going to be left with x squared plus 5x minus 24. And then you have to figure out what gives me negative 24 but also plus 5. So x plus 8 and x minus 3. But remember, because you multiplied by 4, you're going to have to divide by 4. This is going to give you a nice number. And this will give you a not so nice number, so you need to get rid of that fraction. Only if you can't simplify. And then you're left with 4x minus 3 and x plus 2. But these cancel, which means you're left with x over 4x minus 3. And then that's your answer. You cannot cancel out the x and the x here because the 4x is attached to a minus 3. Okay, so just kind of putting everything we've learned together. Alright, so let's look at number 1, and then I'll do 4. So it says to find the sum or difference, write the answer in simplest form. So same thing, I'm going to combine my numerators, but look to see my denominators are the same. That's good. So I'm going to combine my numerators. So n plus 3n, that's 4n. And then keep the denominator. Because 4n, they're attached by multiplication, you are allowed to cancel stuff out and simplify. So this will turn into 1. This will turn into 2. So you're left with n over 2 as your final answer. And then you're done. Okay. What I'm actually going to do is I'm going to put the answers here to see that they check out with mine, because I think sometimes I make little mistakes. Alright, now I'm going to do 4. So same with 4. My numerators, the denominators are the same. That's good. My numerators, I'm going to combine them if I can combine them. 7p squared minus a p squared, that's technically a 1 there. This is going to give me 6p squared. And then we're left with 4p cubed. So now, because again, these are attached by multiplication, okay? Multiplication, I can simplify stuff. So I'm going to simplify these by 2. This is going to give me 3, and that'll give me 2. Now, quotient rule here, the exponents, you can subtract them because of quotient rule. So that means I'm going to be left with 3 at the top, and then 2p, because I'm going to do 3 minus the 2, and it stays at the bottom because it's bigger. So then that's how I get my answer. Okay. Alright. Let's go on to the next one. Okay, for the next one, I'm going to do number 6. Alright, so for 6, same thing. Or, you know what? I'm not going to do 6 actually, because you should be able to do that one. I'm going to do 7. Alright, so same thing. Denominators are the same. Numerators, combine them. 5x and 20, you cannot put those together. These are not like terms, so you're going to have to leave it alone as 5x plus 20 over x plus 4. But if you notice this, you can actually factor something out. So I'm going to factor out a 5. And then I'm left with x plus 4. These cancel out and you're left with just 5 here. And let me just make sure that answer matches. And it's 5. Alright, so you're going to do number 8. Okay, I'm going to help you just get started so you can see. So same thing, combine like terms. You're left with 2w. And then you're going to be left with 9 plus 7, which is going to be 16. You're going to have to factor the top. Okay, so go ahead and factor that. And then simplify. And I'm hoping it gives you the answer that is right here. I don't know if you can see it, but I think that was, or I don't remember what it was, but you'll be able to see it. Alright, so, w plus 8 over 5. Okay, alright, so these are the easy ones. Okay, we're kind of just going through these a little bit. Let me see. I will do, I will go ahead and do 11. Okay, alright, so for 11, same thing, denominator is the same, keep it. The numerator, I cannot combine those, so I'm just going to rewrite it as c squared minus 4. But c squared minus 4 can be factored to c plus 2 and c minus 2. And then you're left with c plus 2 at the bottom. So then your answer is c minus 2. Okay, number 12, I'll help you get it started, but I'm not going to do it. So from this one, you're going to combine like terms for the numerators. So you're left with 2m plus 6 over 8m plus 16. You're going to have to factor both of these. So you're going to have to factor out a 2 on the top. You're going to have to factor out an 8 at the top. Cancel until you get the answer. Alright. So now let's move on to these, because these are a little bit more complicated. Okay, so let's start off with an easy one, number 13. So same thing, combine your numerators. We're left with v plus 8 because you can't put them together, so you have to just write them together. Your denominator is v squared plus 5v minus 24. Now I can't factor out the v plus 8 anymore. That's done. However, I can factor the v squared plus 5v minus 24. Let me write it over here. V plus 8. So this is going to be v plus 8 and v minus 3. These will cancel. That's how we get a 1 at the top. So it'll be 1 over v minus 3. Okay? Okay, so we have like bases. So I'm just going to go ahead and combine the like terms at the top. Be left with 3n plus 2. The reason I have a plus 2 is because this is minus n minus a negative 2, so it's plus 2. Then 3n squared minus n minus 2. I'm going to go ahead and factor. I can't factor the top, but the bottom I can. Now these are not like terms, so you're going to have to go ahead and do that whole fraction. Be left with n squared minus n minus 6, n minus 3, n plus 2 divided by 3 because you multiplied by 3. So I'm left with n minus 1 and 3n plus 2. These cancel. I'm left with 1 over n minus 1. And that checks out. Alright, let's move on. I'm trying to pick some of the harder ones. Alright. Let's do 17. So now from this one, we're going to go ahead and the good thing is they're all like terms. So it looks like there's a lot going on, but they are all like terms. So let's go ahead and combine, they're all like the common denominators. The top, they have like terms. So let's combine our like terms, and the bottom stays for our denominator, which is x squared minus 4. Okay, so x squared, there's nothing to combine it with. Plus 1, I can combine that, but I'm going to write my b's next. So I have 5x minus 2x, that's 3x. And then I have 1 minus 11, which is 10. Okay, so now I have, sorry, not 10, it's negative 10. Because this negative here makes that negative when you distribute it. So now you're left with x squared plus 3x minus 10. So now let's factor. We're left with x plus, or sorry, plus 5 and x minus 2. So that gives me negative 10, but also plus 3. And then x plus 2 and x minus 2. These cancel out. You're left with x plus 5 and x plus 2. Now again, in case you're wondering why is that 10 negative, it's because you're doing 1 minus a positive 11, which is the same as 1 minus a positive 11. That's the same as 1 minus 11. That's how I got negative 10. Just in case you were confused on how I got that negative 10, because at first I put positive, but that was a mistake. Alright, let's look at the next one. I really can't tell which ones are hard because they kind of look easy. So let's try, hold on. I'll go ahead and do number 18 and 19. I will not do 20 because 20 has a fraction. I want you to do the fractions. I already did one for you. So now for 18, I'm going to have 4d squared minus, actually, I'm going to write it up here. So 4d squared minus 28d over 6d cubed minus 42d squared. Now the good thing is they're common denominators, so that's why I just rewrote it. Now I have to look to see, okay, what can I factor out? I can factor out a 4, and I can factor out a d, so 4d. We're left with d minus 7. And then down here, I can factor out a 6d squared, which will give me d minus 7 again. These cancel out. I'm left with 4d over 6d squared. Now, because these are attached by multiplication, I can simplify them. So I'm left with 2 over 3. Now, because of quotient rule, I'm going to subtract these. So I'm going to be left with because d squared is bigger than d to the first power, it has to stay at the bottom. So that's how I'm left with 2 over 3d. And then that's your answer. Alright, number 19 is the last one I'll do for these notes. So I feel like I did quite a few. Alright, so now for number 19. Common denominators, check. Rewrite them. Numerator, there is nothing you can combine. So I am just going to write it together. Oh, lucky you, there's a fraction again. So I will do this one because I already said I will do it. But number 20 also has a fraction anyway, so Alright, so for this one, there's no GCF. You're going to have to do that whole fraction work that we do. So I'm going to be left with g squared minus g minus 30. Okay. Then we're going to be left with g minus 6, g plus 5. Divide by 2. We get g minus 3, 2g plus 5. So now I'm going to change the color. So I get g minus 3, 2g plus 5. We're left with 2g minus 5 because that's a perfect square minus a perfect square. And 2g plus 5. So minus 5 and plus 5. These cancel. You're left with g minus 3, 2g minus 5, which is what I had. Alright, for number 20, same thing. I'm going to go ahead and combine like terms at the top. I'm going to be left with 2w minus 1. Now, the reason it's minus 1 is because I have a minus plus 1, which is going to turn into a minus 1. The denominator is the same, so I'm just going to keep that. Okay, now the top I can't factor, but I can factor the bottom. Again, it's going to be one of those factoring. So w squared plus w minus 2. Then we're left with w plus 2 and w minus 1. But again, you're going to have to divide by that 2. So I'm left with w plus 1 and 2w minus 1. These cancel. I'm left with 1 over w plus 1. And again, that checks out.